Need to see those?
The cylinder.
Cylinder
I
what?
feel like I did it right, but I didn't get the right answer.
Cylinder?
It's because you're asking for the lateral surface area, not the whole surface area.
That's correct.
I
So, does somebody have the stats on it?
6 inches high, 4 inches long.
6 inches high and a 4-inch from the center to the outside, and we are after the lateral surface area. Who would like this problem? Rachel,
Okay, so the lateral surface area is asking for just this part. If that makes sense. So everything except the 2 circles. So what we have to do for that is we have to kind of just think about this. So you've got if you were to take it out, you'd have 2 circles, and then you'd have the area between them.
she just made what we call
A net.
a net.
Okay. So we know that when we put this around the circles, it fits all the way around and it stops right here. It fits perfectly. So all we have to do is find the circumference of the circles, because that's equal, the circumference equals the length here. So the circumference of that equals the length there. Okay, so we know that the circumference of a circle is 2 pi r. And then we also know that the height here is 6. So we have to do 2 pi r times 6. So what's our r? Our r is 4. So we have to do 2 pi times 4 times 6. And I don't remember what the number was, but that's 8 times 6, so 48 pi equals, and then what was the answer? 150.8. Is that right?
You okay?
Makes sense?
Yeah.
Anybody have any questions? It really helps if you can visualize that cylinder. And we're only interested in the lateral, so that means the 2 bases are not included. And when we open it up, the circumference is nothing more than the length. Well, think about it this way, you really don't have to memorize formula after formula after formula, you just make sense of it, okay? And again, I'll just repeat it, you don't remember, go back to how we discovered it and rediscover it again. Okay, do we need to do the sphere one as well, or are we okay?
Yes.
Yes, okay. Do you have the data on that one?
Yes. What is the volume of a sphere that has a radius of 5 centimeters? And then round your answer to the
We want volume. Who wants that one?
So, I just use like the formula, so it's 4/3 pi and r to the 3rd. So the radius was 5, so I did 5 to the 3rd, which is 125. And then I just did it through and multiplied it by 4/3, and I just did 3.14. And I got 523.3 repeating. So I just used the formula.
Anybody verify that? Is that? She's right to here, but I
got 523.6. I think if you use different, like, because mine said it was right, so I think there's like a range of.
I did give you a little bit of leeway because, did I tell you what to use for pi? So some people might use 22/7, some might use 3.14, some might hit their pi button on their calculator, and so you'll be off just a little bit. So I gave you a little bit of a leeway as far as, okay?
I was just wondering on the testing, is there a calculator for these calculations or?
Yes, your calculator is fine. Any calculator is okay as long as you don't carry formulas into the testing center in your calculator. And those of you who know how to do that, you know what I'm talking about, and those of you who don't worry about it. I think if you're comfortable with a calculator, I hate to say, well, you can't use a graphing calculator, and yet they do have the ability to do that if you. Let's move to the skill review test for the measurement unit. Are there any questions there? In fact, let's just do this. If you've got a question, let's get it up on the board. You either go draw the picture, the figure, or whatever, put the number up there, and then we'll let somebody volunteer to go up and do it. Okay? So, you want to come up and, are they the same ones or different ones? Okay. So, when we're done here, we want everybody to have understood everything about all the problems in the review. Erase any of the old problems if you want. Yeah.
As we move from discuss review into the next thing.
Questions?
I don't know, somebody just walk us through it.
I-
Walk it through.
In
I
plain
just-
English, please.
Okay. So, we know that we have this 60-degree angle, that's this wedge that's cut out. And a cylinder is 360 degrees around. And so what I ended up doing was looking at it and say, okay, 60 degrees is what of 360 degrees? It ends up being 1/6. So I know that I've got 1/6 of my volume that's cut out. And so I have 5/6 of the volume that I'm finding. And so I just had the cylinder which is pi r squared h for the height, times, I'm only finding 5/6 of the volume. So I've just got the cylinder formula times 5/6, and then I was just plugging in numbers. So it's 3 squared, which is 9, times 12 is the height, and then 5/6 I just reduced because you had 6 and 12. 6 is going to 12 twice. You end up with pi 9 times 2 times 5, and 9 times 5 is 45, times 2 is 90. Sorry.
Everybody see how I got the 5/6?
Yep.
If 1/6 is gone, 5/6 remains, right? Okay.
This is for Eric, I guess. So would that be the same as finding the whole volume and then
Yeah.
finding, like taking away, dividing by
1/6.
6 and taking away one of those 6?
Yes, you
That
could,
would work just right.
yeah, you could do this and then subtract this times 1/6 or divided by 6, and it'll give you the same answer. I just didn't want to add in an extra step, and so I was just like, I'll just do 5/6.
But if that's the way you think about it, that would work. Did everybody hear that? I'm going to actually put that up. We would have pi r squared h, that's the whole thing, right? Minus 1/6 of pi r squared h. So we take the whole cylinder and then we subtract 1/6 of the cylinder out. That would be the same. Did we do this one? Does it need to be done? Do we have someone else that could come up and... Somebody who hasn't been up today? What is the key when you're finding surface area?
Private area.
If you want to score points on your test, big points, when I'm grading it, and I'm the one grading it, then this is how you will do it. Because I don't care if you make little teeny, I care, but the little teeny mistakes don't cost you the big points. You've got to get the big idea. And if I can tell you know what's going on, I will see out to the side of it, I will see a net or pieces that form a net. Does that make sense? So what will that look like when I open this all up and put the pieces flat?
2 circles and a rectangle.
2 circles and a rectangle. Where do the circles come from?
The top and the bottom.
The 2 bases. Will they be complete circles?
Nope.
So I will have to do this, right? I should see that. And this is 60 degrees, right? Okay. What's this? What's the rectangle?
The circumference of the circle minus the wedge.
The part that comes around the back, right? Okay. So how high is it? 12. This is how long? Might as well label a bunch of these. This is how far? Two pi r if it came all the way around and joined, but it doesn't. It's only, let's go back to this problem. It's what? 5/6 of the circumference. Okay? And r we know is 3. We might as well put that in there. I get these 3 pieces added up. I've got it all. That's all I've got to paint. That's all I've got to put the contact paper on, or whatever we're doing with this. What else? I've got to put paint on this and this. What shape are they? Rectangles. Okay, they're going to be rectangles. How many? 2. 1 for each side. Can everybody see that those pieces here, and then this is the piece that goes around the back, the top and the bottom. I better see that kind of a setup on your paper. Now, how long is it, or wide is the rectangle?
3.
Because that's this right here, which is 3. What's this? 12. And I've got 2 of them. So 3 times 12 is 36 times 2. 72. You might even go up here like this and put 36 and 36. And up here, 3 times 2 is 6, but the 6 in the bottom cancels with that. I'm left with 5 pi times 12, which is 60 pi for that area. Here we've got, what's the circle formula? Pi 3 squared times what? 5, 6. And so one of these 3's cancels with the 3 in there. And I've got the other 3 times the 5 is 15 pi for this one and 15 pi for this one. Now what? Add them all up. 15 and 15 makes 30, 30 and 60 make, and you probably ought to have a statement down here to that effect. 15 pi plus 15 pi plus 60 pi plus 72, and this all makes 90 pi plus 72, and then this is in inches, so we'll go what? Cubic inches, square inches, plane inches, what? Inches squared, because it is, and if you want to leave it just like that, that's fine. Or if you'd like to approximate it, that's okay too. But I would write that, and then I would write your approximation out to the side.
Isn't it 15 divided by 2 though?
Is it?
Yeah, I think you left out the 2.
Oh, yep. See, so what if you had done that very thing, and this was worth 10 points? You'd probably get 9, at least 8, but probably 9 on something like that.
So you just divide the total by 2?
Because I can see you've got everything. There's just that we forgot to take 15 over 2. So 15 over 2 and 15 over 2, that means there's only one of those, right? Yeah. So that should be instead 75 pi plus 72. Thank you. Little teeny mistakes are only cost you little teeny points. But if you miss the whole overall thing that this is what you're doing, if I can't tell that you understand the problem, that's when you mark off the 8s and the 10 points out of it. I try to give you credit for everything you do that you show me. So don't do anything in your head, or don't do it all in your calculator and then write the final answer down. Even if the final answer is right, if this is worth 10 points and you've got the final answer correct but no work shown, 2 points. That's all you get. Okay? Now, is that being hard-nosed or? No. I don't know if you have been following the Common Core. If you haven't, you better get following it, because you're gonna jump into a teaching situation where you will be expected to teach there, unless you go to Alaska or Texas or Virginia or Minnesota. I think those are the only 4 states that have not adopted the mathematics Common Core, and they already have, those states already have a pretty robust, very Common Core-like curriculum. And I have been online, in fact I was on this morning looking at the released items that Smarter Balance, one of the assessments that all of your students will be taking beginning, not this coming school year, but the year after that. And guess what they're doing? They're asking you for questions. Let me bring some of those in and show you what students have to do at the various grade levels. You will be astounded what they're going to be asked. And many of the questions, not all of them, but many of the questions say, justify your answer. One that I looked at this morning was this. Let me see if I can remember the figures. 14-inch diameter pizza costs $15. A 10-inch diameter, so this is the large, this is the medium. A 10-inch diameter costs $7. The class is trying to decide, should they get 2 of these or 1 of these? And the determining factor is which gives you the most pizza for the money. This is an 8th grade exam. And so you have to say, well, this is the one I would buy, but then you have to say, here's why. Should you buy 2 mediums for $7 a piece, or 1 large at $15? Now, we know this is the most money, but maybe it's the most pizza too, and maybe it's the most... Well, are we interested in perimeters here? Are we interested in volumes? Are we interested in area? What are we interested in? You got to know that to begin with, and then you've got to know how to do your computations and make your... Anyway, I'll bring some of those in. It said right after this, tell how you decided. Okay? Did somebody already do this one? Nope. Can somebody do this one? How did you think about it? How did you...
No, I didn't get it right. So what I was thinking was like 2 quarts is like 2 jugs of milk.
Yes, that's what you ought to be thinking. 2 quarts. If you don't have a picture in your mind for something that's a quart, you need to. Do you can fruit? If not, get something else. But how big is a quart? You should have that idea in your mind. And a cup, how big is a cup? And then 12 cups would fill, would that be a quart, or would it be more than a quart, or would it be...
4 quarts is a gallon, right?
4 quarts is a gallon.
2 quarts is just
How many cups in a quart? Well, a pint, there's how many pints in a quart? You guys should know these. 2. And how many cups in a pint? 2 cups in 1 pint, so 4 cups in a quart. So 16 cups in a gallon if you have one. So this isn't even it's 3/4 of a gallon. Can you see a picture of that? A gallon of milk, I've only got 3/4 of it. And this is a large watermelon. Well, a large watermelon is bigger than a whole gallon, right? And so 2 quarts definitely wouldn't work. Now what about these other ones? Milliliters. Do you know what a milliliter is? What's a liter?
It's like this.
Yeah, 2-liter bottle of soda. What's a milliliter though?
It's smaller.
It's smaller than that. How much smaller?
1,000.
1,000th of a liter. So there would be 2,000 milliliters in a bottle of soda. And so I don't even have a half of a 2-liter bottle, right? That's too small. By the way, a milliliter is equal to a cc. Do you know what those are?
Cubes.
Hmm?
It's like 1 a shot.
For a shot, that's right. Anybody heard of that with a syringe? Do you know how many in a syringe, how many cc's fit in a syringe? Depends on the size of the syringe, right? But cubic centimeter is, could you hold up your fingers and say a centimeter is about this far? Is it, I mean, is it this far, or is it that far, or is it this far? How far is a centimeter? I think you should know. That's why I'm asking you these kinds of questions. Centimeters about that far, so you have a little box that's that big, about that tall, and it holds a cc, 1 cubic centimeter, which is the same as a milliliter. You just kind of get an idea of it. But yeah, this is 3/4 of half of a 2-liter pop bottle. Right? You should be able to think about those kinds of things from your daily experience. Paying attention to those kinds of things. That's, did we get all the questions from the skills test answered?
Mine's just like, I kind of, yeah. Can you draw a polyhedron that has 10 vertices, 15 edges, and an appropriate number of faces? Do you want us, like, because I know how to find the faces. Yes.
You
but
know
do
how to
want us-
find the answer, but drawing it is the
Yeah.
hard part?
Yeah, so I said no at first, and I was like, okay, I guess yes. I don't know.
Can you? No, I can't.
No, I can't draw it. So,
Is the question supposed to be, is it possible?
because isn't it a 3D, and so you can't draw it, is what I was thinking, so it's 3D.
I do want you to draw it. That's what I meant by doing that.
Okay.
Yeah.
Could you draw that?
Did anybody get one drawn? It's got what?
10 vertices, 15 edges, and that means
10 vertices, 15 edges, so our faces would be what?
7.
Why?
Because the formula F plus V minus E equals 2.
F plus V. What's that?
Times E.
Minus E equals 2. Is this the right formula? There are other variations of the formula. You can do F plus V equals E plus 2, right? Or, I mean, you can put your F plus V minus 2 equals E, or there's lots of variations. Don't memorize this. Why are you laughing?
Because you've said that about every formula.
I say that about everything. You need to make sense of it. You need to... This formula is very similar to what? Euler's formula for... This is Euler's formula for polyhedron. For what?
Network.
For networks. For networks. They both have, except here the faces become the regions in the network, including the unbounded region. Do you remember that? And there's a 2 in both. It's the exact same formula, except there's an R here. How come? I was gone that day, I think. Did the connection get made? Yes? No? All right, here's why you shouldn't memorize it. Here's why you should never need to memorize it. You should say, oh, Euler's formula, it's got faces, edges, and vertices in it, and a 2. But I can't remember how they go together. It all just, especially 3 years from now, you'll remember that there were faces, edges, and vertices, and probably a 2. So what are you going to do? You're going to go to the very most common polyhedron of all, which is a square box, a square prism, a cube. And you're going to say to yourself, this is so easy to do. How many vertices? Right? 8 vertices. How many faces? Top, bottom, front, back, left, right. 6. How many edges? You should be able to get it really quick. 4 around the top, 4 around the bottom, and the 4 that connect the top with the bottom. That's 12. So now you've got a 6 and an 8 and a 12 here, and you're going, ah, that's where the 2 comes in. Right? Then you're saying, well, how should I make this? Well, you can do 6 plus 8 minus 2 equals 12, or you can do the 6 plus 8 minus 12 equals 2, whatever you need to do. Just put your formula together. You get on a test, just draw yourself a real quick cube and bring these numbers out and say, oh, I can resurrect the formula by myself. Don't memorize it. Okay? Now, supposing I built a cube out of Tinker Toys or straws with gumdrops or toothpicks with gumdrops at the corners. And if I were to shine a light on my cube that I built with toothpicks, and if I shone it right straight onto it, I would get something like this. I'm just shining the light, and since the one that's behind is further away, it appears to be smaller, right? That could be what I see. Are you with me? How many vertices do we have? Still 8 in this network. How many edges? 1, 2, 3, 4. The 4 around the square in the front, the 4 around the square in the back, and the 4 that connect the front to the back. That's 12, right? 8 vertices, 12. And how about regions? 1, 2, 3, 4, 5, and
6, the outside.
the unbounded region, which for us is really the face of the cube that is here. Does that make sense? I'm trying to tie the network formula to the polyhedron formula. It's the very same one, except regions and faces are the same. Does that make sense?
So that picture, it's like you're shining a flashlight, you said?
I've got it built out of the toothpicks and whatever, and then I'm just shining a light, and this is the shadow of what I see. Right? It's a little different view than this one right here. It's like, these are the toothpicks, and those are the gumdrops where I stuck it together, and that's what I would see. Is that helpful? Do you see why you don't need to memorize it? Really? Either one of them? They're both the same. So if you want the network one, but you can't remember how to do it for the cube, and then turn faces into regions. Okay. What else? Oh, so we need to get one that was, yeah. So how many faces did we end up with?
7.
7. So, can anybody think of a figure, a three-dimensional figure that would have 7 faces? What might that be? Yeah. Yeah, a pentagonal or a pentagonal. I've heard it said both ways. I'm not correcting you, I'm just saying be aware that some people say it differently. And how did you get that?
Well, I thought I needed 7, and I knew that most shapes have a top and a bottom, and so I subtracted 2 and I got 5, and that's what I got.
Do you see how she did it? So, you draw yourself a pentagon on the top and one on the bottom and connect it with. And doing it 3-dimensionally is a little bit different than 1-dimensionally, but and then something like that. And now count it. Make sure you've got it. 1, 2, 3, 4, 5 on top. 1, 2, 3, 4, 5 on bottom for a total of 10 vertices. We have a top and a bottom and 5 lateral rectangles. That's 7. And the edges, 5 around the top, 5 around the bottom, and the 5 that connect the top to the bottom. That makes 15. Okay?
How did she think pentagon?
How did she?
Yeah, why did she think pentagon?
She said, I've got to have 7 faces. If it's a 3-dimensional figure and it's got a top and a bottom, then there'll have to be 5 things around the side. And then it turns out that it fits everything. Okay?
The other nice way is, since all of these prisms, the way that it looks like they're set up, you have an equal number of edges on the top, the connection, and the bottom. And so if you have, like, it has 15 edges, if you find the factors for 15, you have 1 and 15, and then you have 3 and 5. And since you know there's a top, a bottom, and a middle, that gives you your 3. And the other factor is 5, so you know that there's 5 edges coming down, or 5 coming around. That's another way to do it.
Another way to think about it. Thank you for sharing. Thank you for sharing that. Okay. Well, when are we going to meet for the review? It opens Friday. Is anybody going to go Friday and take it? Friday morning? Nobody takes it the first day, right?
Friday
Take it in the evening.
Friday afternoon, 4:30. And we'll go till 5:30 or 6, or if you have more questions. You bring your questions, I'll bring some sample problems, and we'll just let you go. And yeah, I think this room will be available. If not, we'll have a note up here showing you where to go and what to do.
No, just speed up the class.
It's 4:30 here.
Everybody needs a partner. 4:30 here in this room, Friday. Bring your questions. Oh, while we're talking about it, somebody said, what's the difference between outcomes and reflections? The outcomes are found on iLearn there, and for each one I need an explanation and a couple or more examples. If you find that in answering those outcomes and explaining them, if you find that that you have already answered that in one of your reflection questions, cut and paste. It's not intended to duplicate, but just cut and paste. The reflection questions, just answer them thoroughly. And then the outcomes, I want an explanation with at least 2 examples of each. Okay? Here's your first. You can't do this alone. You cannot do this alone. You've got to get with a partner. Let's see, 2, 2, 2. Okay. Kim, would you and Rachel work together? And I think everybody else maybe turn around and work there. All right. It really helps if you and your partner use your paper and I am going to do the first one for you so that you know. Your partner has a paper that looks like this. Your paper, if you put it down, you can either turn your paper, you can slide your paper, you can flip your paper over, and when you do, you and your partner should be able to make a word. Everybody see my word right here? What is it? Icebox. Okay, I've done one for you. Every single one of these, you have a half of the word, your partner has the other half, and you need to make the word. As soon as your partner have found a word, come up and use my overhead and show me what you got.
This one's probably
Get up there.
So we got sons, right? Symmetry.
No, might be a different word. What word?
tripping on through this.
I did icebox. Where did you want to written?
I'm gonna sneak past.
The words you want them written.
No, I just want you to go up and show the class how you and your partner got the.
It has to be it's an actual word?
Yeah, it's an actual English word. Flip it.
Did I not do it right?
No, flip it again. Top to bottom. Flip it.
What's the word?
Flip it like this.
Oh, you're doing mirror.
Oh, just kidding. Sorry.
What word is it?
You're doing mirror.
Mirror. Everybody see the word mirror?
I was like, I think it's right.
Four, right?
Like that. So there's a line. It's with the line on the other one, so like two lines.
Symmetry. There's symmetry. Okay.
Sorry.
Good enough. Okay, we've got sons, we've got symmetry, we've got mirror.
I got excited. All right, or is it backwards?
I don't get this at all.
Is that it?
Oh, there's Dad. Wait, is that it?
Oh, yeah.
What does it say? Fantasy. Fantasy. Not only does that one say fantasy, but so does that one. Fantasy, right?
It's the same one.
This one. I'm turning it over, back and forth.
It's kind of like, so
that.
fantasy and symmetry, the way they're written, they can be flipped upside down.
So here's sons, right? And here is sons again. Huh. Sons of a gun. Here's mirror. Right? Mirror, and there is mirror again. What else have we done? A nice box. Ice box. And here is ice box again. What else have we done? Oh, symmetry. symmetry, and there's symmetry again. We got them all?
No. A little fox.
Who can dance? Oh, can you get it? You think you can get it?
Other ones aren't done.
Oh, CE.
Yeah.
There's those two.
Sweet.
Hi, Heron.
Echo.
Not only does that one say echo, but so does that one. Come on, you dancers, get up here. We got them all?
No, we're missing 3 and 7.
Here comes another one.
I'm not very good at this.
Oh, that's Echo? Okay, so
Which one? Ah,
What is that word?
does it look better if we go like that? I miss you so much. Okay. Oh, not only does that one say myth, but so does that one. Okay, we got one more, right? No, I think we've done them all. Yep, we did. We're done. What? 5? Did we do 5?
yeah. So you got Icebox,
5 is dance.
left to right, no. Icebox, dance, myth, Echo, myth, symmetry,
Okay. This helps to introduce one of our main themes of the unit, the upcoming unit, symmetry.
And lag, basically.
By the way, this comes from a book by Scott Kim, and it's called Inversions. I recommend it highly if you're artistic. This unit that we're about to begin, if you love art, and those of you who are elementary teachers, which are most of you, you always try and incorporate things together. So you have a little project, and you could do a math, you could do art, you could have them write about it, you could, lots of different things. Symmetry is one of our big ideas. The other big ideas will come out in these 2 problems that I gave you. See what you can do to solve these 2 problems. Before we're done with the unit, you will be able to solve them this quick with some really slick techniques. But there are lots and lots of ways of solving them. And so read that over and kind of say, where is this next unit heading? Anybody played mini golf? Okay, there's a little mini golf course there. This will actually help you, this unit will actually help you get better at mini golf. And if you love to play billiards or pool, you'll get better at that as a result of our unit today. That is our unit. Practical stuff. Go bet on your pool.